The Lockheed Constellation, affectionately known by many as the Connie. One of the most elegant and aesthetically pleasing aircraft to ever take flight. But being a thing of beauty was not its only grace. Lockheed took a giant technological leap to give birth to the Constellation. It was a leap so far ahead as to give Connie a lease on life, extending long after many of her prop-powered rivals rusted into obsolescence in the era of the turbojet. Her perfection of form and function can be traced to the dawn of commercial aviation. She was the end product of years of battles between the airlines for dominance of the skies. This struggle for economic survival would see the airlines and airliner evolve into their ultimate modern forms and unite the globe through air travel. In the late 20s, the fledgling American airline industry was still using aircraft like this Ford trimotor with its fixed landing gear. Technically primitive aircraft, by today's standards, and capable of short hops between cities only. Intercontinental airlines still relied on railways to ferry passengers for part of their trips. In this early age of aviation, the rules governing airlines and safety were still being written, sometimes lagging behind quickly evolving aerospace technology. Although not as dangerous as a ride with a daredevil barnstormer, a commercial flight could still be a risky proposition. A fatal crash in 1931 opened the world's eyes to the perils of flight. That year, TWA Flight 599 came down in the Kansas Prairie, killing famous football personality Knute Rockne and 7 others. Rockne was a passenger on another type of trimotor, the Fokker F7. Unlike the all-metal Ford trimotor, it had wooden wing components, and moisture may have weakened the glue holding them together, causing them to fail during flight. Rockne was beloved by the American public, and the Rockne crash, as it became known, led to major changes in commercial aviation standards. Some improvement in speed, safety, and comfort were seen early in 1933, when the Curtiss Company launched the Condor airliner. Though it was a biplane and had a traditional frame and fabric construction, it had a tubular metal wing spar. The Rockne crash caused wooden aircraft to become the pariah of the airlines. As commercial flights became longer, passenger comfort became a greater priority. The Condor was the first aircraft to offer sleeping berths for overnight flights. Like today's airliners, it also had its own galley, providing fresh hot food and beverages for its passengers. Only about 40 Condors left the production line, and it did advance the passenger airliner, but an innovative new aircraft from Boeing would set the next benchmark for civil aviation. Boeing's Model 247 was breathtaking in comparison to anything else available, and all the airlines wanted it. It was faster than the fastest American fighter of the day, and it could beat the Condor across the USA by 8 hours. It was also a safer, more comfortable plane for its 10 passengers. It was all metal in construction and could fly on a single engine if one should fail. As well, the cabin was soundproofed and air-conditioned. The 247 was a solid design that could have dominated, but corporate greed got in the way. Boeing sold 60 of its aircraft to its affiliate airline, Boeing Air Transport, part of UATC, the predecessor to United Airlines. TWA and others were clamoring to get their own 247s, but their orders were to be postponed until the entire United order was fulfilled. Locked out, TWA and other airlines turned to aircraft manufacturers Douglas and Lockheed to build their new fleets. From Lockheed, the company that would one day create the Constellation, came the Model 10 Electra. Like the 247, it could initially carry 10 passengers, was of all-metal construction, and had twin engines. By this time, single-engine aircraft had been banned for all passenger and night flights. Kelly Johnson, then a student assistant at the University of Michigan, did much of the wind tunnel work on the Electra. He was a champion of the Electra's twin tails, which would later become a hallmark of Lockheed aircraft. Johnson would become a leading light at Lockheed and contribute to the Constellation's design. The Electra was a decent alternative to the 247, but Douglas had an aircraft in the works that would eclipse both of them and come to dominate civil air travel. TWA had turned to Douglas when their 247 orders had been rejected. The airline was looking for a new tri-motor, but Douglas answered with a groundbreaking line of aircraft. The DCs, short for Douglas Commercials. These twin-engine, all-metal aircraft had the range and seating capacity to knock all competitors out of the sky. From the prototype DC-1 to the DC-2 to the DC-3, seating went up from 12 to 14 to 21. In terms of performance, the DC-3 could fly eastward across the USA in 15 hours, with just 3 refueling stops. Hundreds of DC-3s were constructed, compared to just 75 Boeing 247s. With so many of their planes in the air, Douglas had a major role in popularizing air travel. But for all the improvements that had taken place, aircraft manufacturers still had a long way to go in terms of performance and comfort achieved by a pressurized aircraft like the Constellation. Pressurizing an airliner would allow passengers and pilots to fly comfortably at higher altitudes and in the jet stream, cutting flight time and fuel costs. But it wasn't until 1937 that the first U.S. experiments got underway. It was in that year that the U.S. Army commissioned Lockheed to modify a standard Model 10 Electra with a new pressurized fuselage. The XC-35 was a watershed in aircraft design. It was an experimental aircraft constructed to prove that it was feasible to fly above the storms. Windows were smaller than found on the Electra for fears of a blowout. All these modifications allowed the XC-35 to fly at 30,000 feet and take advantage of the jet stream. The age of pressurized aircraft had arrived. With this new technology in hand, airlines were looking ahead to a time when they could offer non-stop, coast-to-coast flights and intercontinental flights, carrying enough passengers to make such trips economically feasible. To do so, they would need an all-metal, 4-engine plane, large enough to carry 40-plus passengers over a distance of 2,000 miles. In 1935, before the first DC-3 had risen into the air, United Airlines had expressed serious interest in an aircraft with these specifications and went to Douglas for help. 5 other airlines joined United's venture, including TWA, each contributing $100,000 apiece to the project. It was a small amount of money compared to the millions their investment might return. Douglas answered their challenging specifications with the DC-4E. It was a 4-engine aircraft that could carry 42 passengers, twice as many as the DC-3, a distance of over 2,000 miles. Like the later Constellation, it had a tricycle landing gear and a triple tail. It also had air conditioning, power-boosted controls, and production versions were to be pressurized. Such an aircraft could change the landscape of civil aviation, but as development costs increased, Pan Am and TWA lost interest. The prototype DC-4E did fly in June of 1938, and testing was successful, but it was too expensive, and performance was below expectations. The project was canceled. In the end, the prototype was sold to Japanese Imperial Airways, who secretly reverse-engineered the aircraft to create the Nakajima G5N bomber. Japan wasn't the only nation gearing up for war. In the late 1930s, with communism and fascism at odds with each other and global tensions rising, war was a possibility, and aircraft manufacturers were preparing for the battles ahead while still keeping an eye on the civil market. Boeing attempted to re-engineer their B-17 bomber to create a new airliner, the 307. Boeing fused B-17 wings, undercarriage, and tail section onto a new, wider pressurized cabin to create the 307. It could fly its passengers in comfort high above any bad weather. However, because of its B-17 heritage, the 307 still had to utilize a tailwheel, making for less safe takeoffs and landings than an aircraft with tricycle landing gear like the DC-4E. Altogether, only 10 307s were sold. At this time, Lockheed was in development of their own four-engine passenger plane, the Model 044 Excalibur, which at first glance appeared to be a larger version of the Model 10 Electra. Howard Hughes would call for radical changes to this design that would reshape the Electra into the ultimate prop airliner. When Hughes gained control of TWA in 1939, he wanted an airliner which incorporated all the latest technology available. But no such aircraft were in the air. On top of his technical requirements, he was looking for great style and extra performance. Funding from the lucrative Hughes Tool Company was the only way Howard Hughes could pay for such an ambitious project. With cash in hand, there was little doubt that he would get his way. The final rendition of Lockheed's super airliner model was so different from the 044 Excalibur first proposed that it was also given a new name, the L049 Constellation. The plans for this streamlined, elegant aircraft fit Hughes's bill for style and performance. Lockheed designers, including Kelly Johnson, borrowed elements from other aircraft to create the Constellation. It was pressurized like the XC-35 and able to fly its crew and passengers at a ceiling of 24,000 feet. As well, its wings were adapted from those of Lockheed's P-38 Lightning, and its triple tail and tricycle landing gear were reminiscent of those of the Douglas DC-4E. Even with such a stellar design in the works, the more primitive Excalibur was not cancelled. It has been suggested that the more modest Excalibur concept had actually been kept in development to distract interest away from the greatly advanced Constellation. This was part of a ploy to keep TWA's monopoly of the Connie. Since Boeing had executed a similar maneuver to keep their 247 out of TWA's hands, there is little doubt that Howard Hughes was capable of such tactics. Just as the contracts were signed and planning for the Constellation prototype got underway, the world braced itself for war. Hap Arnold, head of the Army Air Force, voiced serious concerns over the rise of Nazi Germany. He stressed the need for a backup for the already planned B-29, a long-range bomber capable of striking the U.S.'s foes wherever they might be. Lockheed was now obliged to develop a bomber version of the Constellation, the XB-30, to play understudy to the B-29. The plan for the Connie's conversion was simple and lauded by the Air Force. Graft a Constellation's wings and tail section onto a new fuselage, housing bombs rather than passengers. In the end, however, there was no need for a backup bomber. Boeing delivered the B-29 Superfortress, and the XB-30 was cancelled. The end of the XB-30 was not the end of the Constellation's military career. In December 1941, when the war came to America, the military took control of the entire L049 project. The Constellation became the C-69, a high-speed transport aircraft for troop movement. In January of 1943, 4 years after Hughes proposed its groundbreaking design, the C-69 finally took to the skies. It was still several months before all engine problems were sorted out, and the aircraft was handed over to the Army Air Force. The second C-69 had a much more glamorous debut. Though it was still a military machine, it was allowed to be presented in striking TWA livery. Even more surprising was that Howard Hughes was allowed to pilot it trans-America on a record-breaking flight, a record at the time equal to any belonging to a modern fighter. A great deal of successful publicity was gained for all concerned, and the Connie was certainly winning hearts, but not that many orders. In fact, the total number of wartime deliveries was just 22, The Army was in desperate need of transport aircraft. They just weren't buying them from Lockheed. After the failure of the too advanced Douglas DC-4E, Douglas went straight back to the drawing board and produced a far less ambitious aircraft, originally known as the DC-4, with no E. It was quickly militarized into the C-54 Skymaster. C-54s had no pressurized cabin, and although they did incorporate a tricycle landing gear like the earlier DC-4E, overall they had a much simpler layout. This made for quicker production, easier service, and greater reliability, exactly what America needed in a wartime situation. With all of these advantages, the C-54s drained away the Constellation's military orders. Between 1942 and into the early post-war years, over 1,200 C-54s and DC-4s were produced. But the aviation marketplace was quickly changing. As World War II ended, aircraft manufacturers had to reverse course and focus their energies on the civilian market. A number of Skymasters found their way into post-war civil use, with some being retrofitted with pressurized cabins. It was in this early post-war period that the Constellation sales took off. Her extra size, more powerful engines, and pressurized cabin all became prerequisite features for a new generation of airliners. Luxury and comfort were now being offered, and the public was willing to pay for Constellation quality. However, Lockheed's competitors weren't ready to concede defeat. Boeing was looking to capitalize on the success and technology of the B-29. They started by creating a new tanker, the C-97. Like the proposed Lockheed XB-30, they took the wings and tail section of an existing aircraft, the B-29, and grafted them onto a new, larger double-decker fuselage. The C-97s were originally built in large numbers as Air Force tankers and freighters. However, it didn't take Boeing too long to see the lucrative potential of the airliner market. The Boeing Model 377, or Stratocruiser, was an airliner version of the C-97. With its second deck providing much greater seating capacity and its extra range, the 377 looked like it would give the early Constellations some serious competition in the luxury airliner market. However, only 56 aircraft were produced. They certainly delivered all that was promised in the luxury department, but they proved uneconomical to run. Also, 2 serious accidents resulting from their complicated engine and propeller arrangement became a source of serious concern. Although the Stratocruiser had only a limited impact on the civilian airliner market, Lockheed and the Connie still had one more player to contend with. When the war was still raging, the Army had contracted with Douglas to make an advanced Skymaster prototype, longer and with more powerful engines, and at last with a pressurized fuselage. At war's end, Douglas would take the prototype and research paid for by the Army and use them to create their new civilian offering, the DC-6. Its overall look was somewhat more sedate than the elegant Connie, but it would still prove a very worthy adversary. Throughout the decade that followed, many modified DC-4s and hundreds of brand new DC-6s and later DC-7s fought it out with numerous generations of ever-improving Constellations. As Lockheed and Douglas tried to capture the imagination and contracts of airlines around the world, they increased the seating capacity, range, and storage of the respective aircraft. With airliners available to take passengers around the globe, the long-range airline business grew in all directions. Luxury travel was augmented by tourist and economy seating. The term coach became common at travel agents and airport check-ins. Lower fares meant higher volume and access to an entirely new market of average middle-class citizens. Douglas continued to provide transports as it had in World War II, while Lockheed created a new early warning radar aircraft, the Warning Star. Over 230 of these advanced electronic surveillance aircraft provided critical support for the Air Force and Navy, especially during the Vietnam conflict. Business was booming for Lockheed and Douglas in both the military and civilian markets, but soon their streak of good fortune would come to an abrupt end. Rival Boeing returned with an unbeatable new aircraft design, which would rattle the foundations of the airliner world, the jet-powered 707. Boeing's president, Bill Allen, had bet the company on this aircraft. The 707's swept wings, potted jet engines, and other advanced technology made the Constellation and DC-6s and 7s seem like antiques from a bygone era. In a brilliant business move, Allen created a militarized version of the 707, the KC-135 tanker, in parallel with the 707, allowing him to save money on research and development and tap into the military and civilian markets simultaneously. In 1957, the same year the 707 took flight, Lockheed unveiled its most advanced constellation, the Starliner. It was packed with new advanced features. The Starliner's turbo compound engines allowed it to fly non-stop from California to Europe. But the aircraft was costly compared to similar offerings from Douglas. As well, airlines wanted to add jets to their inventories, not only for performance, but for prestige. There was more bad news for Lockheed on the military front. Although the Warning Star would continue to play an important role as an early warning aircraft into the Vietnam War, it was ultimately superseded by the Boeing E-3 Sentry, a radar-equipped version of the 707. Douglas and Lockheed both attempted to wrench the jetliner monopoly from Boeing, but only Douglas was able to crack the market successfully with their DC-8. DC-8s and 707s battled for air supremacy, just as the DC-6s and 7s had competed with the Constellations in the years leading up to the jetliners. In the mid-70s, Lockheed did attempt a comeback in the airliner market with their jet-powered TriStar. 250 aircraft were sold, but it was far below sales targets. Lockheed exited the civilian market once and for all and instead concentrated on military aircraft. Constellations, once the most advanced airliners in the world, were gradually phased out. They were relegated to backup roles, shorter routes, and ultimately served as freighters. Connie, the Queen of the Skies, was a victim of old age and progress and had to abdicate her throne to the jetliner. She aged gracefully, serving smaller airlines up until the 1990s. Civil aviation went through several revolutions since the early trimotors hopped across the U.S. In this time, airlines rose and fell, and aircraft manufacturers pushed technology forward as they battled for their share of the civilian market. Today's network of airlines and aircraft unifying the globe are the end result.
The Lockheed Constellation was one of the most important aircraft in rebuilding of the airline industry after the war. Often described as the Queen of the Skies, it was the most powerful and advanced airliner of its time. A combination of many technical innovations came together in a true success story. In addition, the distinctive curves of the fuselage and the perfect balance of the design made the plane a thing of beauty and grace. Large four-engine transports are not always aesthetic, but the Connie's lines demand admiration. The Constellation was the pinnacle of piston engine transport design and broke new ground in both civil and military variants. However, its career overlapped into the jet age, and the appearance of new technology brought down a premature curtain on its lifespan. The Lockheed Company, with a heritage stretching back to 1913, had painstakingly built up a reputation for constructing excellent and trustworthy passenger aircraft. Commencing with the Vega and following up with the Orion, Lockheed's reputation blossomed. They became associates with the famous names of aviation between the world wars. Wiley Post and Amelia Earhart both flew Lockheed aircraft. The second list of records set in Lockheed's planes grew rapidly. The company products were not simply a successful reworking of the day's technology, they were innovative and influential. Lockheed had a succession of talented designers. Jack Northrop was followed by Gerald Voltee. When both of these men had gone off to found their own companies, Lockheed retained the services of a team led by the greatest engineering double act in aircraft history, Paul Hibbard and Kelly Johnson. Lockheed developed an excellent family of fast twin-engine transports in the Electras and the Lodestar, carrying between 10 to 14 passengers and what was comparatively only moderate discomfort. In 1938, Howard Hughes piloted a Super Electra around the Northern Hemisphere in just over 3 days and 19 hours. Hughes' respect for Lockheed was cemented, and later he turned to the company into trying to fulfill his aviation ambitions. The flight, of over 14,700 miles, confirmed a view held by many, including Hughes, that civilian airliners would be the mass transit method for the future. And to do this, the individual plane would need to carry many more people over much longer range. Lockheed had already been working towards this with their Model 44 Excalibur. Designed to carry 36 passengers, they were more than receptive when Hughes approached them on behalf of his airline, TWA. His basic specification was an aircraft that would fly a payload of 6,000 pounds from New York to Los Angeles, non-stop, in 8 to 9 hours. He would be a 4-engined, pressurized, luxury airliner cruising at around 300 miles an hour. TWA had set the parameters for capacity and performance, but it was the Lockheed team which designed and built the plane. It drew on many successful elements of their earlier studies. The wing was expanded from that of the P-38 Lightning fighter. The triple tail, originally designed by the Douglas Company, had been tested in the Model 44 project. Kelly Johnson was intimately concerned with the new project. Here in the wind tunnel, cameras catch him changing the shockboard in one of the long series of model developments. Because the plane drew so much on the work done for the Model 44, it was initially referred to as the Excalibur. However, it acquired a new number, the Model 49, and soon was given a new name as well, the Constellation. Lockheed's main rivals had been leapfrogging each other in airline development, with Douglas reaping the majority of the awards in America along the way. However, they did not have a client with the determination and checkbook of Howard Hughes to support them, and their designs were transitional rather than attempting one giant step. Lockheed had conducted a lot of relevant research and development during the 30s, and this had equipped it well to approach the new design. The company had been involved in pressurization experiments with the Army, and Electra had been modified for the tests and given the Army designation of XC-35. The plane first flew on the 7th of May, 1937. With the information derived from these tests, Lockheed were able to devise the Constellation system. This maintained cabin pressure at ground level up to 9,000 feet and restricted pressure to that of 8,000 feet when the plane was at 20. The XC-35 was, in effect, a practical advantage that Lockheed held over their rivals. In a similar way, a lot of expensive development of the wing shape had already been born in the design of the Lightning. Even with these advantages, the cost per constellation quoted to Howard Hughes was, for the day, astronomical. Hughes' determination funded the development from its first meetings with the company in June 1939. However, its progress was slow. Many design problems needed to be overcome in reaching the stage where production would commence. Perhaps because the company had not built such a big aircraft before, Lockheed's team were very flexible about their approach. The series of decisions that set the Connie shape serves as an example. Large engines working at low revs were less likely to feel stressed and break down. So, a combination of such engines with large propellers were suggested. The large propellers demanded absurd ground clearance and very long forward undercarriage. To shorten that wheel strut, the nose is bent down. The large area of disturbance from the propellers suggests the triple tail will not work in flight. However, a more efficient single tail will not fit into a hangar. The solution? Curve the fuselage upwards and take the triple tail out of the propeller turbulence. The plane that results has a straightened S for a centerline in the side view of the fuselage. And it works. As a bonus, it's also beautiful. The first Constellation went not to our Hughes airline, but to the United States Army Air Force. War had swept up the US, and civil aircraft production had become another arm of the war effort. Wartime pressures delayed the Constellation further, but eventually, on January 9, 1943, Project 49 took to the air for the first time. The first plane was the production prototype. There was no transitional model. Existing commercial orders had been drafted even before the US entry into the war, and by 1942, the Army added orders for 300 of the type, most with a more powerful engine. Now being military aircraft, the first Constellations were given a military number. They became C-69s. The test series was delayed due to the trouble with the engines, and the first plane was not handed over to the US Army Air Force until July 29, 1943. In the time the plane was grounded, Lockheed and TWA took the opportunity to repaint it and do some publicity shots. Some of the testing was also conducted in TWA livery and was used for publicity. This was nothing compared to the publicity coup pulled off by Howard Hughes with the second machine. The plane had been delayed in production and made its first flight only in 1944. It was accepted by TWA on behalf of the military on April 16, painted in TWA's colors, though showing its military serial number. The following day, the plane took off with Hughes himself at the controls. It flew non-stop from Burbank to Washington, a distance of 2,300 miles and a record time of 6 hours and 57 minutes. This was an average speed of 330 miles an hour, a respectable speed for a fighter of that era. In addition to the successful publicity for Hughes and the TWA, The event spotlighted the Constellation to the mutual delight of Lockheed and the Army. After the record flight, the plane was kept in Washington for a week of displays and inspections before being delivered to the Army. Over the next 18 months, the C-69s were to make a number of significant long-distance flights and set a series of records. These included excessive transatlantic records, reducing flight time to Paris to under 10 hours. It was evident that the Army had found in the Constellation a valuable personnel transport. The C-69 could carry up to 64 fully armed troops, or alternatively, was capable of transporting a light tank or other medium vehicles. The underworked big engines returned excellent fuel consumption figures and combined with the plane's range, speed, and capacity to put the Constellation far ahead of its competitors. While this was not that relevant in 1945, it would be a telling advantage for Lockheed at war's end. Even though there was a clear need for cargo planes, the Army never placed a high priority on Constellation construction. Under Army direction, Lockheed concentrated on production of other warplanes. In addition to its own Hudson and Lightning designs, the company was heavily involved in construction of Boeing's B-17. Most of Lockheed's experience with four-engine planes during the war was with the Fortress rather than with the non-belligerent Connies. Lockheed produced many thousands of aircraft during the war, but only 22 of them would be C-69s. Army orders for hundreds of C-69s were never fulfilled. Only 15 had been delivered when the war ended, with another 7 planes almost completed. In addition to Lockheed's production being directed to other types, the Constellation used the same engines as the B-29 Superfortress, and few of the power plants were allocated to the program. The engines had teething problems, and the shortage curtailed production. Testing was disrupted with frequent groundings of all types using them. At war's end, 12 of the 15 planes delivered to the Army were declared redundant. All military orders were cancelled, and Lockheed paused to consider their options. The decision was made to go ahead with the Constellation as the company's primary product. In the anticipated post-war expansion of commercial travel, while their competitors tried to rebuild bombers into airlines or upgrade their pre-war designs, Lockheed were ideally positioned with a tested and proven aircraft that was very advanced in comparison to any other type available. By buying back C-69s from the Air Force, including those partially built at the factory, Lockheed were able to offer customer airlines new aircraft almost at war's end. Pan Am were the first to receive these refurbished Army planes, and the Connie made its first commercial flight on the 3rd of February 1946. 3 days later, TWA introduced its Constellation service, first on the transatlantic route, and then a month later commencing transcontinental flights in the US. Competing carriers were mostly relying on DC-4s, and the Connie had no problems outperforming the older Douglas plane. The efficiency of the Constellation was undeniable, and within 2 years, TWA's rivals on the transatlantic route had been forced to change to the Lockheed plane themselves. In effect, the Lockheed decision gave them an 18-month lead over their competitors at Boeing, Douglas, and Republic. This was clear to the airline operators as well. Within a week of the war's end, the company had orders from 8 airlines for over 100 Constellations. The contracts total over $75 million and allowed Lockheed to retain its skilled workforce as production of the Connies was stepped up. The original batch of ex-military planes was soon used up, and new examples started to roll from the factory. Though intended for civil use, they were still the basic C-69 as ordered for the Army. The plane had reverted from its military designation to the Lockheed project number. Thus, the basic aircraft was referred to as the Model 49. During the war, Lockheed had advanced 5 further studies for improved Constellation variants, and these were given an extra numeral. The first being the Model 149, second 249, and so on. One of these projects have been for a long-range bomber variant of the plane, but the other 4 were all transport versions, 3 being improved civilian airliners. There were 73 civil Model 49s, including the recycled C-69s. Their immediate availability after the war gave Lockheed the time to refine the Connie further, before releasing the first truly civilized version. For some carriers, the purchase of Constellations propelled them into the big league. KLM was one. As early as November 1946, they had transferred their transatlantic route to Lockheed Model 49s, and the Connies served the airline well from then to the mid-50s. By that time, KLM was a major world airline, with a massively expanded network of routes. Work on what was to be the first civilian production model had begun in May 1945. This was the Model 649, developed in conjunction with Eastern Airlines. Among the many developments introduced with this model was the SpeedPack external cargo bay. This was another example of Lockheed's team lateral thinking. A Connie offered little cargo space when laid out for maximum passenger carriage, but had the power to spare. To avoid cutting back on the number of passengers, additional cargo space was bolted to the outside of the plane. This increased the goods carriage by 8,000 pounds, at a penalty of only 10 miles an hour in speed. The model also introduced a new and more powerful version of the engine, rated up to 2,500 horsepower. The 649 first flew on October the 18th, 1946. It was a notable advantage on the Model 49 in many aspects. Major improvements have been made to soundproofing and cabin air conditioning, giving a far more pleasant ride than any other airliner at the time. Easton began to advertise their planes as their gold-plate Connies. They began operating services in May 1947. Overlapping with the deliveries of the Easton 649 came another new version, the 749. This had been developed as a long-range model for overseas operation, based closely on the Eastern aircraft. The outer wings contained additional fuel tanks, which added a further 1,000 miles to the range of the plane. With this version, the New York to Paris route could be flown non-stop. Further improvements to the 749 were recognized with the sub-designation 749A. Air India was the first to employ these, bringing them into service beside the earlier Connies then purchased. The improvements made to this version were directed to obtaining a higher gross takeoff weight, bringing an additional nearly 5,000 pounds to the payload. The weight of the Connie had grown markedly during her career to that time. The initial C-69 had a maximum weight of 72,000 pounds, but this had been expanded to 107,000 pounds with the 749A. At the same time, the range had been increased from 2,400 miles to well over 3,000. Many of the improvements made to these planes were later built into earlier models, blurring the distinctions between the earlier versions. The Constellation stood at what was to be the pinnacle of propeller-driven airliners. The technology of propellers themselves was very highly advanced. With its fully reversing blades, the Connie could pull itself up on landing in a very short time, or could back itself into a parking bay. The props could also be fully feathered to reduce drag if an engine cut out. Extreme use of the reversing props on landing produced this sort of spectacle, with the Constellation not only coming to a halt in a very short strip, but promptly backing up. The Connie's props been carefully matched to the huge engine chosen for the plane. The big blades caused some problems with the undercarriage in hoisting the plane clear of the ground, but these problems were offset by the advantages gained in flight. The big engines were run at very low revs, with no stress and minimum fuel consumption. They were quite capable of keeping the big plane aloft, even if two were cut out, and even if both of the engines on one side had to be shut down. By settling the plane to demand so little of its power plants in normal operation, Lockheed built in an enormous reserve. The 749, a specification had originally delivered from the renewed military interest. The original C-69s had been a problem aircraft for the Army, due in no small part to the experimental nature of design. The Army was well served by its large fleet of Douglas DC-4-derived C-54s, and abandoned the Lockheed plane. But when in 1948 the new U.S. Air Force turned its attention to the Connie, it was no longer a new design that pushed the state-of-the-art under wartime handicaps. This time, the Air Force bought a minor variant of the well-proven airliner as a C-121A. Two were immediately redesignated as VIP aircraft and allocated to General MacArthur, who transferred the name of his old C-54 Bataan, and General Eisenhower, whose plane was known as Columbine. Later, VIP Connies were assigned to Eisenhower after he became president and were named Columbine II and Columbine III. The non-VIP C-121As were used as cargo and personnel transports, and had strengthened floors and large rear fuselage cargo doors. Over the next few years, the original Air Force order of 10 aircraft were all reconfigured as VIP planes. The first was delivered in December 1948, and the last in March 1949. They soldiered on for nearly 20 years of service and were not retired until the late 1960s. The return of the Constellation to Air Force service was followed by interest from the Navy, and a new military role dawned for the plane. The C-121's career was to be very long and very influential, and redefine the military use as large transport aircraft. By the time of the Columbine III, President Eisenhower's plane was a much different proposition from his first Constellation. In the development of this new type, the story of the Constellation returned to its beginning, to the first C-69 built. This had displayed its military number 310309. However, its company number had been 1961, and it was as old as 1961 that it was to gain its individual fame. During the war, the first Constellation had served its share of Army duty. During this period, it was re-engined with Pratt & Whitney radials, as an emergency-driven response to the chronic problems with the Wright double cyclone engines. After this refurbishing, the Army took to calling it the XC-69E, though it was otherwise unchanged. At the end of the hostilities, it was then put up for sale and bought by none other than Howard Hughes. In 1949, he sold it back to Lockheed and a transformation began, as it was turned to the prototype for the Model 1049. The most obvious change was that the plane was stretched, and two new sections of the fuselage were built into it. One section before the wing added 10 feet and 9 inches, and the second behind the wing 7 feet and 8 inches. The alteration was so radical that the company marketed the plane under a new name, the Super Constellation. TWA had again been involved in the development of the plane, but Eastern Airlines had lodged its actual order first, and so they received the first Super Connies. In addition to the obvious lengthening, there were many other improvements. A better de-icing system for the wings, stiffed wing surfaces, increased fuel capacity, and more powerful engines were all incorporated. The gross takeoff weight of the plane increased by only 12%, but such was the efficiency of the design that the payload increased by 40%. Seating was available to cater for between 69 and 109 passengers, as the Lockheed devised a variety of layouts. Some were designed for long-range carriers and others for commuter airlines. Other plans with fewer seats catered for routes with a higher proportion of freight, or allowed for the removal of fitting to use the aircraft as a part-time cargo plane when passenger traffic was light. The company's intent was clear. The Constellation had given them a captive market they did not want to lose. The new planes were assembled in Lockheed's appropriately named Hall of Giants. The first version had only a limited lifetime. It had been intended to give a new and revolutionary turbo-compounded engine, but teething problems with the new power plant that led to the use of standard, though uprated radials. The 2,700 horsepower delivered by these engines left the Constellation slower than its rival, the Douglas DC-6, and only 24 were built. Lockheed were forced to persist with the introduction of the more powerful but underdeveloped new engines. Though problems persisted, the strategy paid off and sales picked up. With the introduction of the new engines, the plane received a further 20% boost in its weight-to-range ratio. All comparisons with the opposition were addressed, and all orders resumed their earlier, hardeningly busy frequency. This beneficial change was in part forced on the company. They had had enough of unproven engines earlier in the Constellation's career. However, the military were very interested in an uprated Super Connie, and much less so in the underpowered original model. Not only did the re-engineering rekindle civilian sales, but the new Super Constellations were to be the testbed for a revolution in military aviation. Today, the concept of aerial command posts, electronic surveillance centers, and radar stations is commonplace. They've proved their worth in time, and again, during their short career. Most of the experimentation that proved their effectiveness was conducted in constellations, as was most of their early service. Again, old 1961 was involved in making aviation history. As with domes above and below, the original plane was used to trial the installations. The first Connies constructed as airborne radar pickets were built for the Navy. They replaced the earlier rudimentary installations aboard converted World War II bombers. Aboard the planes, a crew of 22 were involved with aircrew, radar operations, and engineers. With their long range coupled to the search range of the extensive load of equipment, these Navy WV-1s proved the worth of the concept and installed it as an accepted part of naval practice. Soon, the idea spread to the Air Force. The Air Force had placed orders for Super Connies for conventional use as transports, but C-121s would not be delivered as such until 1956. Before any transports could be built, the Air Force acknowledged their better use as an airborne early warning aircraft and changed the order for the first 10 to its own flying radar pickets as RC-121Cs. These planes are loaded with 15,000 pounds of radar equipment, with crews at 335 miles an hour up for 24 hours on patrol. The RC-121C was similar to early Navy Super Connies, with their height-finding radar housed in the 8-foot-tall hump, and the bearing scanner located in the ventral dome. The RC-121Cs entered service in 1953 and were mostly employed in patrolling the western seaboard of the USA. They were followed in 1954 by the first of an order for 72 RC-121D Warning Star aircraft. In addition to the passive role of detection, these incorporated offensive activity as the control centers for the guidance of fighter interceptors. From the basis of the Morning Star, a number of options presented themselves. Once, the idea of putting equipment into aircraft was suggested. There was a rush of ideas about which equipment might be suited for the treatment. Advanced electronics and surveillance types multiplied. As the transport planes appeared, they were often pulled back to the factory for refit as one or another of the electronics versions. The appetite of services for these valuable aircraft was insatiable. Over 220 of the main types alone were built, disregarding the one-offs and the small runs. Most of these planes were also completely re-equipped at least once in their lifetime. Between the Air Force and the Navy, over 25 different designations were used to identify versions of the radar-equipped Connies and their control center brethren. In addition to proving the concept and paving the way to their success, these constellations also performed very real service in an era when there was no other practical solution. At the height of the Cold War, when hostility and distrust often combined in equal degree to foreign policy, a calmer picture of reality was maintained by these electronic eyes in the sky. In 1962, the RC designation was changed to EC, and the electronic Connies were to earn their later Vietnam fame under that designation. They were a pivotal factor in the US defensive strategy, and had become as important as the cargo-carrying versions that were dispensable. Despite using non-standard fuel and requiring piston engine maintenance that was in almost dead arc form, the Connies were nursed along. Old age and technological redundancy could not undermine their essential functions, and some were to remain in service until the early 1980s. Their longevity was helped not only by their experts' care, but by the excellence of their original design and construction. The jet age was, however, drawing in on the Constellation's career. It was obvious that the introduction of the jet airliners would change the whole market expectation, and Lockheed were determined not to be left behind. Aware of the limitations of early jet technology, they set about refining a system of compound engines, or jet props, using jet engines to drive propellers. They had already extended the piston engine by the use of turbines driven by the exhausts. These had added 20% more power to the engines and with the peak of the piston engine development. Employing a jet and prop combination was designed to extract maximum economical efficiency from both technologies. Once again, the testbed for aviation milestone was old 1961. In its last major notable achievement, the venerable airframe was fitted with an Allison turboprop in the outboard starboard position. This engine couldn't save the Connie, but it was part of the foundation of one of Lockheed's most successful aircraft, the C-130 Hercules. It was also at the heart of the successful Lockheed Electra, which kept the company alive in the civilian market. However, for the Constellation, its success as the pinnacle of piston engine airliners somehow acted against anyone taking a jet-powered version seriously, even though the finest development, the Starliner, was yet to come. With a new wing shape and other major revisions, The Starliner carried Lockheed's hopes of continued dominance of the long-range airliner market. However, though orders for Super Connies didn't dry up immediately, there was no flood of orders for the new plane. Only 44 of the vastly improved version were built, phased out of service relatively quickly, being replaced by jets. The improvements made to the Starliner were numerous, and it was undoubtedly the finest piston engine airliner of all time, but it was too late. Lockheed's enterprise imagination and innovation continued to work around the Constellation, and several refinements, including the now familiar revolving antenna, were developed and tested with Connies. The new development of the Starliner gave Lockheed a proposal to put the Air Force, and the company invested considerable time and money sorting out the best package it could develop around the plane. The revolving dish was only one of the systems developed for the submission. With turboprops, extended range, specialized layouts, and a large number of new features and improvements, the Starliner was being prepared for what would be the next sales opportunity. By then, the success of the airborne radar and control planes that the fleet of such an aircraft be maintained. The aging C-121s would need a replacement. By the time the competition was announced, Lockheed knew that no matter how excellent their proposal was, they didn't really stand a chance. Hot on the heels of the formal call for tenders came the specifications, and these confirmed Lockheed's fears. Time had stolen a march on the military Starliner as well as the civilian version. The Air Force was not just in the market for a replacement, but for their constellations to be more precise. They were in the market for a jet-powered plane. The Boeing company had the world's best such aircraft on its catalog. Developed for the Air Force as a jet tanker, the KC-135, the result of a foregone conclusion. However, the appearance of the replacement did not signal the end of the Connie's military career. Whereas the arrival of Boeing's jet had seen the quick demise of civilian constellations, the Air Force and Navy were content with the capabilities of the plane. And coincidentally, they had need of them. The U.S. Air Force C-121s, to be based in the Asian theater, arrived in Thailand in April 1965. Although Navy planes had been the first Connies involved, starting with the missions in August 1964 at the time of the Gulf of Tonkin incident, the Constellations flew throughout the war and their service was invaluable. They performed in a number of functions, some of which were developed and tested as a response to the armed combat raging below and in the air around them. The big plane's commodious fuselages saw many refits. The variety of constellations deployed to Vietnam illustrates the way the big planes had taken on so many roles for the services. Their main work was as an airborne early warning aircraft, but they were also used for a number of other missions. A few cargo versions were used primarily for aeromedical evacuation and as passenger planes. However, beyond that, the specialist electronic planes filled a number of roles. One of these was the relay of data from sensors scattered along the North Vietnamese supply routes as a part of Operation Igloo White. To have diverted the jets to these tasks when they were needed as refueling tankers would have been highly impractical, and the Connies, available and reliable, soldiered on. The Constellation's original deployment to Vietnam was essentially defensive. They were to be used to provide a radar picket to guard against North Vietnamese bombers attacking targets in the south. However, this proved to be a short-lived need, and the duties that kept them in the theater were over a broad spectrum. One of the most unusual roles the Connie was called on to perform fell to this plane, and in C-121J of the Navy's Development Squadron, PX-8. The designation was given to a group of planes that were variously modified to secret specifications. There was no conformity within the designation. It was effectively a grab bag for various one-off Connie versions. This plane, for example, had its own special fit and its own special mission. The equipment fitted to this plane was definitely non-standard in military terms. These 2-inch tape players were the ultimate in professional television formats at the time. The duty of the aircraft was to serve as television and radio broadcaster for the armed services networks. By hauling the transmission aloft, the service was taken out of range of the ETCONG interference. Ground-based transmissions would have required infrastructure which, as a tempting target, would have needed constant guard. The quietly plotting Constellation transmitting from on high made the maintenance of the service broadcasts practical. Of course, most of the Constellation activity in Vietnam was far more actively involved in the conflict, with most of the important work being performed in monitoring the North Vietnamese. As soon as the operations over the North began, the Constellations became essential factors in the struggle. As the war went on, their role gradually evolved from passive to active involvement. Operating over their own ground, the North Vietnamese MiGs were given very accurate information about the whereabouts of US aircraft in their airspace. This advantage was at first simply countered by the operations of the US radar planes, which were able to relay similar information about MiG activity to the American strike aircraft. As the war went on, the Connies increasingly assumed a more active role, making direct contact with American fighters and guiding them in attack on any North Vietnamese activity. When the North became better equipped with missiles, the Connies were able to fix the location of any SAM site radars that were operating. This served 2 purposes. It warned the aircraft in the area to expect trouble, and it led the Iron Hand Weasels to attack the sites. The last Constellation operations in the theater were flown in May of 1974. Well after the last operational strikes by the US forces, the big observers continued their monitoring. By then, it was 25 years after the first electronics refitted Connie, and so impressed the Navy. It was also 31 years after the first Constellation flight. When the Constellation was at its peak, the axe fell. They were forcibly retired from service long before they wore out. The major airlines were forced, partially for reasons of prestige, to abandon props. The Connies have been the key to the establishment of long-distance civil traffic after the war, but business has no place for soft sentiment, and they were abandoned quickly. By the early 60s, the civil career of the Constellation had moved to small airlines and lesser routes. There, they continued to work for many years. Gradually, they become relegated to cargo, and then lingered further as isolated crop dusters and fire tankers. The military career lasted much longer, with the last Navy Constellation being retired in June 1982. The last Constellation built had been delivered in 1958. 856 Connies were made in 16 years of production. Their career stretches from World War II to the Space Shuttle. They were, throughout their career, used as test beds for a multitude of developments. The results of this service are still seen in use in both military and civil aviation today. One of the most beautiful aircraft ever produced, time reduced their worth to weight in metal. Very few escaped the scrap merchants, and now they're treasured museum pieces. If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.
Aviation, the art of aeronautics, began with the dreamers, inventors and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.